Alright, lesson 66. We're going to talk about simplifying of radical expressions. And this is very closely related to a topic that we've already done. And you can see the example that I have on the screen where it has the radical 240 or the square root of 240. Now what we're going to do on this example, which we've already done, is we're going to simplify this. And remember, we've already talked about a radical is not simplified if the number has a factor that's a perfect square root. Now remember, your perfect squares would be 4, 9, 16, 25. I'm just going to list a few of these out. And you can see that these are some of the factors that we want to try to use. Now, let's think of two factors of 240 where one of them is a perfect square root. Now, the first thing I notice is that the first couple digits consist of the number 24. And I know that 4 will go into 24. So I could think of 240 as 4 times, let's see, 4 into 24 is 6, and then add a 0. So 4 times 60 is 240. So when I try to simplify a radical expression, I need to make sure I have one of the factors being a perfect square root. And 4 would give me that situation. Now, what's this mean? It means the square root of 4 times the square root of 60. But the square root of 4 is 2. So really, I have 2 radical 60. Now, the problem is that I'm still not done because 60 has a factor that's a perfect square root. Test it for 4. You know, 60 is even, so try 4. And you'll find out that 4 times 15 is 60. So I have 2 radical 4 times 15, which means 2 times radical 4 times radical 15. But square root of 4 is 2. So I have 2 times 2 times radical 15, or in other words, 4 radical 15. And now I am done because 15 does not have a factor that's a perfect square root. Now, we could have made this process a lot shorter if I would have recognized that actually 16 is a factor of 240. So if I have radical 240, I could have thought of 240 as radical, or 16 times 15. Because 16 times 15 is 240, which means the square root of 16 times the square root of 15, or in other words, 4 radical 15. And notice I get the same answer, but in a lot shorter way. Either way is fine. Sometimes you might not pick up that that largest perfect square factor. Now let's take a look at example 1. Now here, and this is the new part, okay, is simplifying of radical expressions. Now so far they want us to simplify this. So the first thing I notice is I have radical 18 plus radical 8. Now we've talked about how you simplify radical expressions. If I had 2 radical 3 plus 4 radical 3, these are like terms because they both have radical 3's, and I have 6 of those radical 3's. Now in example 1, I don't have like terms. So I cannot add them as they are. But they're saying that I can simplify this. So that where I start is going through this process right here. So I'm going to take that radical 18, I'm going to simplify it. And I'm going to think of 18 as 9 times 2. Again, give me 2 factors of 18 where one of them is a perfect square and 9 is a perfect square, right? Now over here, I'm going to think of 8 as 4 times 2, with 4 being the perfect square. So on each one of these, I have a perfect square. Now I'm going to simplify these. So here, this means the same thing as square root of 9 times the square root of 2 plus square root of 4 times the square root of 2. Now 9, square root of 9 is 3. So I have 3 radical 2 plus, let's see, square root of 4 is 2, and then times the radical 2. Now what do you notice? Now I have 2 terms where they both have a radical 2. These terms are like terms. Now I can add them together. 3 of the radical 2's plus 2 of the radical 2's gives me 5 of the radical 2's. And I'm done because 2 doesn't have a factor that's a perfect square. So what we did here is we simplified each of these in the hopes that eventually I would get some terms that are like terms, and that did happen. All right, example 2, simplify. Now I have 3 terms, right? Now right now, none of these are like terms. So what I need to do is I need to simplify each of these radicals. So radical 27, let's see, give me 2 factors of 27 where 1 is a perfect square. Well, 9 times 3. Okay, minus 3. Now give me 2 factors of 18. And we had that in our previous example, 9 times 2, right? Where 9 is the perfect square. Minus 6. And remember, don't forget about that number that is in front here. You know, keep that number in front. You can't just all of a sudden decide that you don't have it anymore. Now give me 2 factors of 45 where one of them is a perfect square, and 9 times 5, right? Now let's continue here. So let's see, this is the same thing as radical 9 times radical 3, minus 3 times radical 9 times radical 2, minus 6 times radical 9 times radical 5. Let's see, back to the left, square root of 9 is 3, so I have 3 radical 3 minus 3 times, let's see, square root of 9 is 3 times radical 2, right? Remember, this is really all multiplication. I don't need to use the raised dot in between, though, in between the 3 and the radical 2, because it does mean 3 times radical 2. Minus 6 times, let's see, square root of 9 is 3 times your radical 5. Now let's simplify this up. So I have 3 radical 3 minus, let's see, 3 times 3 is 9 radical 2 minus 6 times 3 is 18 radical 5. Now I have 3 terms. Are any of these like terms? And as I look at that, let's see, I have a radical 3, I have a radical 2, and I have a radical 5. None of these are like terms. I cannot add or subtract anything here. This is my final answer. And notice that it is simplified because none of these radicals have a factor that's a perfect square. So I'm done. That's all I can do with it. All right, example 3. Let's simplify one more expression. All right, so first thing I notice is I have 2 terms. I have the 2 radical 18 minus 27. And actually here I forgot my radical, so it's minus radical 27. All right, let's see what we can do with this. So let's see, 2 factors of 18, 9 times 2. Minus, give me 2 factors of 27, where one's a perfect square root, 9 times 3. All right. Now this means 2 times radical 9 times radical 2 minus square root of 9 times radical 3. Now on the far left, so I have 2 times 3, because the square root of 9 is 3, times the radical 2, minus 3 radical 3. Well, 2 times 3 is 6, so I have 6 radical 2 minus 3 radical 3. Now, these are unlike terms because I do not have the same radical in both of them. So again, there's nothing I can do from this point on. This is my simplified answer. So I cannot take 6 minus 3, again, because these are unlike terms. Now, if both of these were radical, just for the sake of example here, how about if I had 6 radical 2 minus 3 radical 2? Then these are like terms. 6 minus 3 is 3. I get 3 radical 2. But that's not the case. So in the blue is my final answer to example 3. So our topic here for lesson 66 was simplification or simplifying of radical expressions.